I love this game. Took me from rags to riches.
So what's your favorite thing, Madonna? Nah, I'm playing. I like music. What's your favorite? I like food. We never recently what like that. That's it. Alright. Well, what's our question though? That's the perfect thing. I like that. Yeah.
In order to find out what the perfect angle to shoot a three-pointer, I need to know three things: the height of the court, the length of the three-pointer, and the height of a person or a player.
This is my chance, I gotta give it all I got. Remember 1 second on the clock, I hit the winning.
Okay, so Vidal said we need to find the height of the court. When we found the height of the court, it was 10 feet. The distance of the bottom of the court to the ball is 22.7 feet, and the distance from the middle of the basket to the ball is 24.8 feet. So what we need to do is find the angle of which the player will shoot the ball. We can't find that now because we didn't have a right triangle. So we cut the triangle in half, and that'll give us two separate triangles, two separate right triangles. And the player is 5 feet. So from this distance is gonna be 5, and this distance up here is 4, 5. Now that we know that, we could use the Pythagorean theorem to find this height. So as you can see, we used c squared minus a squared equals b squared. We're using c squared minus a squared because now we're looking for b and not c. So c is 22.7, a is 5.5, and we don't know b squared at the moment. So once we did the square of 22.7, it was 515.3. The square of 5.5 is 30.3. Both are rounded to the nearest tenth. So once we subtracted them, we got 484. To get rid of the square on b, we decided to square a root, and we square rooted 484, which gave us 22 feet, rounded to the nearest tenth, but the tenth was 0, so it's 22 feet. So b is approximately 22 feet. So now that we know that b is approximately 22 feet, we could use this to find these angles. So we decided to use tangent of x sub 1. So tangent of x sub 1 is opposite over adjacent, which is 5.5 over 22. So once we did the division, we got 0.25, and we decided to use arctangent to cancel out the tangent with the x1. So once that canceled out, we decided to use arctangent on the other side, and since that can't cancel out, we kept it. So x sub 1 is equal to arctan of 0.25, which gave us x1 is approximately 14 feet. So now that we know x1, we need to find x2. So the tan of x2, opposite over adjacent, is 4.5 divided by 22, which gave us 0.20. So tan x2 is equal to 0.20. So we used arctan again to cancel out the tan, arctan on the other side, and that does not cancel out. So x sub 2 is equal to tan negative 1.20, which is approximately 11.3. So x2 is 11.3. So now that we know both angles, we need to add them up to get the whole angle, which is 11.3 plus 14, which gave us 25.3, which is what we think is the perfect angle to shoot a three-pointer.
With a magic, I know you're proud of me, mama. Your son is a star, and I owe it all to you. You sacrificed a lot, now I'm on pace to get that #1 spot. And I haven't forgot to get back to my community, extend myself, give someone else an opportunity. Cause if I can help, I'll help you. Cause I know life at the bottom ain't nothing nice, let me tell you. I'm a role model that rolls with me, and every time I get it, just like I hit the. But
Okay, so our first sub-question is, does the height of the ball's release point matter? So we took two shots into consideration. We took Vidal's shot and professional basketball player, a retired basketball player, Ray Allen. So Vidal, when he shot, the ball was at 5 feet 5 inches. That's the height of the ball once he released it. So Ray Allen when he jumps at the apex, he releases at his apex, or the highest point of his jump, which puts the ball at an astounding height of 9 feet when he releases the ball. What this does is it gives Ray Allen a larger margin of error because it's a shorter distance from the basket. Because when Vidal shoots, Vidal has to shoot at an angle, which is the longer way to shoot. Other than Ray Allen, he's shooting at a straighter line, and that gives him a better chance at making the basket. So that's why when Ray Allen has a higher percentage of 3-pointers made than Vidal. So what this means is that the release point of a ball does matter because it gives the player a larger margin of error. What we want to know is, does the rotation of a ball matter once you shoot it? So we did a little research and we found out that it does. Like we used Ray Allen before. Ray Allen, when he shoots, he does 2 back rotations per second once the ball releases his hand. What this does, it causes the friction once the ball hits the backboard or the rim. It slows down the ball, which gives it a higher chance of making that 3-point, because the less speed of a ball equals more accuracy.
In every game, from the bottom to the top, I can't be stopped. I give it all I got, now I'm worth a whole lot. I live for the pressure, I work for the fame, and put it all on the line, each and every game. Haha, yeah. NBA ballers, Phenom, exclusive. Sound scan on the track. CIU, the dean of the industry.